So far, we have discussed the complete property and the mechanism of electric current. But I want you to recall, to generate the electric current, I simply place the two electric plates that are positively and negatively charged. But obviously, that thing is not feasible in real world. Practically, we cannot put the two plates and generate the electrical current. To do so, we use a device that we call as cell. I hope every one of you already know and have seen that how the cell will look like. Let's see here. So how we should define the cell? Actually, cell is a device that will do the work on the electrons to energize them and to generate certain potential difference. While doing that work, actually cell is storing the electrical energy inside the conductor, that is known as the electrical potential energy. So here in this cell, you can see that we have a certain amount of positive and negative charges. What this means? This means that this charge is doing work. This charge have been doing work to push all the electrons to its one side. Now, these electrons are highly energized. They carry a lot of energy. While flowing, actually these electrons will lose their energy and we have to take the use of that energy. Now, if I attach any conductor, what will happen? The current will start flowing. We define this electrical work, let's say W as work done by charge. We also denote it with epsilon, that is work done by the cell divided by per unit charge. Now, apart from it, we have some more devices that we will be using. First, let us try to understand the line diagram, that how we will specify this cell. As you can see here, this is how we define a cell in a line diagram. Now, first try to understand what the line diagrams are. Line diagrams are necessary to simply make any circuit. Circuit means the combination of devices that we are learning one by one. The combination of cell. This cell has one negative plate. This long one is positive plate. Thus, the flow of electrons will always from this negative to this positive, and the flow of current that we'll call the current is in this direction, that is from positive plate to the negative plate. In a very similar way, we can combine multiple cells and make a battery. This is how we show a battery by using the line diagrams. This is our battery. That is, we connect multiple cells together in a series, like one cell, another cell and another cell. Again, one side positive, one side negative. This long line is nothing but a positive plate. In this case, again, the current will flow in this direction and enters from this direction. Now, apart from this, if you recall, we learnt about the resistances in the previous class. Resistance are the devices that we'll use as an external resistance. What will happen? While connecting external resistance to any cell or a battery, we'll actually consume the energy that the electrons inside the battery in a cell will have. First, try to understand that how we denote any electrical resistance. To denote a single resistance, we use external resistance. Here we have a variable resistance. This we denote with a simple arrow. Now, I just want you all to keep in mind that these two resistances are not the internal property of any conductor, but they are the external resistances that we'll apply to control the energy or the energy conservation that any charge will carry. After this, I'll explain you more about the circuits, that is the combination of all these. Now, let us try to understand how we have the electrical resistance or the external resistance in our real life. I think most of you have already seen this somewhere. These are the small resistance that we use in our chipsets to control the energy flow. Now, I'll just show you one simple photo or a table that will explain you how we categorize the amount of resistance, or the quantity of this external resistance, that is the ohm. As you can see in this table, we have the different color codings. These color codings are actually help us to understand the amount, that what amount of resistance these external resistance will carry. Like, see here, if I'll ask you what is the value of this electrical resistance, can you tell? Yes, we can tell. We just have to see the color coding. Here I have 4 bands. We'll start from the green. If you recall from the table, the green takes the value 5. What violet takes? This violet color, which is the second color, it will take the value 7. And here we have orange color that will take the value 3. And then we have the silver here that will carry the value 10. Now, how we should define it? We'll simply define it like the resistance or the amount of resistance comes out to be 5, 7. The third value we'll take as 10 to the power 3, and this last value, that is silver or golden, we'll take as the error, so plus minus 10. This is the value of the resistance of this given resistance circuit. Well, that's all for this video. In the next video, we'll talk more about the energy analysis on any circuits, and we'll satisfy ourselves with the Kirchhoff's voltage and the current laws. Till then, keep learning and keep exploring.